Welcome back. We had a ghost in the machine, I guess, when we were doing our Trig Basics right smack in the middle. So we're going to pick it up where we left off, which was, I believe, right here. Let's see. Coterminal angles. Let's go there. Okay, and what are they again? To recap. All right, anytime you have angles that end up in the same spot, all right, that share the same terminal side, you've got coterminal angles. So let's take a look. All right, and I believe we were using 100. I think that's what we were doing. This one, let's get this out. Cross-country teams doing it distance. They're going right now. All right. So let's say I give you 100 and I say, give me two other angles that end up in the same spot over there at 100 degrees over in the second quadrant. All right, that's 100. Okay, we said you could add or subtract full turns and end up in the same spot. So full turn, nice and easy. Okay, adding 360 would put you at 460. Subtracting 360, negative 260. Hey, now don't forget the degree symbol. Kind of important. Every time you leave that off, by the way, first of all, I'll take off point off, but in reality, you just told the world it was 460 radians if you don't put the degree symbol. So very important starting today that you do that. Okay, so we did coterminals. All right, where to next? Can't remember if we did complementary, supplementary. So I'm going to hit those again. I am. And we'll do, a little physics there. Get this back. Bingo. Complementary, supplementary. You remember these from geometry at least. Complementary meant that you had two angles that added up to 90. And supplementary, they added up to 180. And we had some people in your class that gave us some helpful hints on how to memorize that. Me, I'm so simple. I just thought C came before S and 90 came before 180. Nothing wrong with that. All right. But let's see. What else did they say? Can't remember them all. I do remember that the C and the O make 90 and the S and U could make 180. All right. But you know, as simple as that is, it is a most missed. Okay, so don't forget complementary 90, supplementary 180. Okay, what are you going to have to do? More algebra 1. So let's see. Let's say I give you, we'll do it this way. If I give you a degree and degree measure angle like 40, I think we used, and I ask you for the complement and supplement, then what am I asking? I'm asking, what do you add with 40 to get to 90 for complementary, 180 for sub? Nobody's going to miss this. Okay, 40 plus, of course, 50 makes 90. Don't forget your degree symbol. And 40 plus 140 degrees gets you supplementary there. Okay, common error on the test. Okay, someone writes this. Let's look. They write this. It ain't wrong, but how about tell me which one of those three numbers is the complement, the 40, the 50, or the 90? If you don't tell me, where should I guess? Usually it's the last thing you write is the answer. Well, the answer isn't 90, it's 50. Notice how I box that up, okay? So degrees, nobody gonna miss this, but what if I change this to radians? Let's take a look at our friend pi over 5. And I'm gonna run you through some algebra 1 adding fractions right now. You got to be good at. Okay, complementary, it's supposed to add up to 90 degrees. Well, you just took a memory quiz on the unit circle. What was 90 degrees in radians? It's pi over 2. And what was 180? It was pi over 1, or just plain pi. Okay, and well, let's go. I'm going to focus you in on this guy right here. Okay, and it's that simple with fractions. You got to think, what do I add to pi over 5? Get pi over 1. Right, and of course you can't add fractions until you get a what? A common denominator. So the common denominator here is 5, right? So I got to multiply this not by 5, but by 5 over 5. I know what you meant when you said 5. Okay, and now watch the way I do it. One of these plus how many of these gives me 5 of these. 1 plus 4 is the correct answer. Okay, never change the of these. Okay, up top, complementary. What's the common denominator? 10. So here I got to multiply by 2 over 2. Here I got 5 over 5. Now what do I have? Okay, 2 pi's over 10 plus, I don't know how many pi's over 10 equal 5 over 10. Yeah, so just like I showed you, you're going to say 2 of these plus 3 of these give you 5 of these. This is the complement. Okay, fractions. And you know what? Shame on me. We didn't do a radian for coterminal. Let's go back there. Add this. Okay. All right. Yeah, there we were doing coterminal, but degrees only. So how about our boy pi over 5? I would like to radian measure coterminal angles. And what's the method? You're supposed to add or subtract full terms, but this time the full term is 2 pi. Now, what's kind of cool, especially teaching you high flying honors crew. All right, I know I'm supposed to add 2 pi, but if you really understand what you're doing, you didn't even write 2 pi. You wrote what? You wrote 10 over 5. It's still 2 pi, but now we can play that game again. 1 of these plus 10 of these make 11 of these. Don't change the of these. And what's minus? 1 minus 10. All right. The poor man's way of doing this is to convert it to degrees, add or subtract 360, yikes, and then convert it back. No. Instead, be good with your adding and subtracting of fractions with the common denominator. Okay, and where does that put us? Almost at the end. We are ready to finish this. So I got 4 crossover formulas with physics here, and I want you to make friends with them. All right. And here's the deal. I'll give you the formulas. Okay. But you just got to be able to use them. So the first one is arc length, our boy Al, and it's S for some reason. That's what they use for distance, equals r theta. And here it is, the most important 5 seconds of this lesson. Theta has to be in radians or we're cooked. Okay, so here is your arc length problem. Okay, it says radius 12, angle theta, you know our girl theta, okay, 30 degrees, and they want this little sliver of the outside circumference, and that's that arc length. We want the measurement thereof. All you got to do is plug in 12 for R, and if you plug in 30, it's wrong. But you're supposed to remember that that's pi over 6 in radians. So when you multiply these, your final answer is 2 pi. Okay? So what if you forgot to put radians here, and instead of pi over 6, you put 30? Okay, well, 12 times 30 is 360 degrees. And what's that? You can convert it to radians now and still get your correct answer. Okay, so 2 pi for that little chunk there. Okay, and not that you care, but what portion of 360 is 30? Okay, 30 out of 360 looks like 1/12. So if we could take the total circumference, which is 24 pi, and take 1/12 of it, look familiar? Who dat? Well, that's 2 pi. Okay, that's what you just did. You took 1/12 of the circumference. Welcome to physics. All right, arc length done. And let's talk about the area of that little wedge, the sector area. So we're going to do the same given. What was it? It was radius 12. Angle 30, and we want to know the total area of this. I guess this is blue cheese since it's blue. Okay, fill it in. 12 for radius, 30 degrees. Oh, that's right. We're supposed to use radians instead of 30 degrees, make it pi over 6. And if you're good with your algebra, what's our final answer? That's 144. Let's divide both of those by 2. Now we got 72. 6 goes into 72, 12 times. And if you're coming to my party, you better bring the pi. Don't forget that. Okay. Good. So that is sector area. 2 more. Let's go velocity. 2 of these. Let's go angular first. Curly dub equals theta over t. That's angle divided by time. And what the hey, we need some given here. All right, let's stick with, what was it? Radius 12, this was 30. We'll stick with those. I just have to add t for you. About 4 minutes or whatever. So how do you find the angular velocity? Take theta, which again has to be in rads. So that's pi over 6 divided by time, which is 4. And you wouldn't believe this, as easy as this is to just plug in those numbers. All right, a major portion of the crew can't finish this. All right, what's going on? You remember from middle school that you're not dividing by 4, you're dividing by 4/1, and then you're gonna multiply by the reciprocal. And now it's not 4 pi over 6, it's pi over 24. Okay, and that is your angular velocity. Okay, and last stop today, linear velocity. Why so many formulas that equal linear wheel? Remember, look up in your notes what was arc length. S was arc length, and it equaled r times theta. Oh, so that's where that came from. And we got a name for this guy, don't we? What's theta over t? Oh, it's right here. That's curly dove times r. Okay, so all three of these are up for your use to find linear velocity. And let's finish this day. Amen. All right, find me the linear velocity for this blue given over there. Now, you could type in, I guess you can't use this one because you don't have S, the arc length. Do you have R, theta, and T? Yes, you do. So you could plug in R, theta, T. Oops, that ain't no T. T is 4. Okay. Or you can just do this one. That's the easiest one. Go ahead and plug in 12 for R, and curly dove we already got right here. And what does that give you? Pi over 2. Did I do this right? Hold on. R times theta. Yep. Or I'm sorry, R times curly dove. All right. And that should be it for us today. So, welcome to Trig. So long, Algebra 2.5.